So again, we talked briefly earlier in the episode that classical physics is deterministic.
Yeah, so like cause effect.
Exactly.
Okay.
Given that I know where Hannah is at this point, she's moving at this speed, I can predict with determinism, basically, that she will be there at this position. In quantum mechanics, reality is not described in that way. So you can't really pinpoint a particle, let's say, in that sense. But what we have at that quantum level is something called the wave function.
Wave function.
Yeah.
Okay.
And think of the wave function as a map of all different possibilities where that particle can exist in. So essentially, it's a function that encodes the different possibilities of where the electron can be.
Wait, what's a function?
Okay, so again, let's maybe not use the word function in the mathematical sense, but just think of it as a map.
Okay, it's a map.
It's a map.
The reality is a map.
Exactly.
Okay.
It's a map, and under that map, you have different possibilities of where the particle could exist in.
Right.
To give you a concrete example.
So like every coordinate on the map is a potential possibility of where the particle could exist
100%.
in the future or in the present or
both. Both.
Okay.
Yeah. You can include time in it, but you can also ignore time for the sake of simplicity. So you can take a snapshot of time. Even at one time, this could exist in very different possibilities. It's spooky.
I was already trying to process like time. I had a thought because like time is a dimension. It's part of 3 dimensions, space-time, right?
4.
4?
It's 4-dimensional space-time. X, Y, Z, T.
Who's T?
Time.
Oh.
So X.
What's X, Y, Z then?
Oh, it's like horizontal, vertical, and yeah.
Oh, so space is in 3 and then time is the 4th dimension.
This is the Einsteinian notion of time.
So does Einstein think we live in a 4D world?
Yes.
Oh, then why do we all think we live in a 3D world? That makes more sense.
We live in a 3D spatial world.
Yeah, but space and time are they're interlinked.
Yes. Yes, 100%. So it's a 4D space-time.
Okay, guys, you heard it here first. We live in a 4D world, not a 3D world.
Yes.
Okay, so back to
maps.
Back to maps. So we have a map. Every place on the map is a potential place that this particle could exist. It's a possibility.
Exactly.
Okay.
And this is where probabilities come in, because each part of this map, each possibility, is encoded as a probability. So
encoded in what?
I think here's where it's very difficult to explain without maths.
Okay, sorry. I'm really gonna like pick into like, because I just want to understand. Okay, so let's just take encoded. It's just registered.
So maybe you can give an example. I can give the example of Schrödinger's cat, famous Schrödinger cat.
Yes, another experiment. Let's get
into it. I'll give a simplified version. There's the sort of normal, typical version. I'll give a much simpler version for the sake of the example.
Okay.
So the thought experiment of the Schrödinger cat goes as you have a cat in a box. And the question is the cat alive or dead? Do you have an answer for that?
Both.
Exactly. That's the correct answer.
I already knew the answers. That's not fair, but yeah.
So essentially, we define this map, the wave function. This map has 2 different possibilities.
Okay.
Alive or dead.
Okay.
And the question is the cat alive or dead? Another way to formulate this question is, in what state is the cat in?
Okay.
In this map, how many different states are there? 2. Alive or dead.
Okay.
And the cat actually exists in a combination, or superposition is the quantum term, but you can think of superposition as a combination of both alive and dead at the same time.
So superposition is like something existing in multiple states at the same time?
Exactly.
Okay, and then but then that makes me feel like an uncertainty is an inherent principle of this.
Exactly.
Because it's really because we don't know from our perspective or our vantage point whether the cat's alive or dead, that it can exist in both these possibilities.
Until you observe it.
Until you observe it.
Exactly.
But as in the present moment that you don't know, the cat is in both states.
Yes, exactly.
Okay.
And then you observe the cat, and then you collapse it into one of these 2 states, either alive or dead.
What determines how it collapses?
This is where the sort of wave function formulation comes in.
Okay.
You have different probabilities. So say you have a probability of half alive, half dead. What that means is if you sort of measure this thought experiment 10 times, hypothetically, you should get the cat 5 times dead, 5 times right. 5 times alive.
Yeah. So that means that it's like half.
This is one possibility.
Okay.
But then, so the whole point of quantum mechanics in many cases is actually to determine the weights of the various states.
What do you mean by weights?
So the likelihood of the cat being alive or dead. It might be 70% alive, 30% dead, which means...
And that's determined by like natural factors, right? Like, did the cat eat? Is it hydrated? Is it sick? Is it, right?
So that's a very interesting point, where, so essentially the factors that determine the likelihoods or the probabilities of the various states depends on a lot of physical parameters. In the thought experiment of the cat, these could be ones of them, yes.
Okay, because it's not like meant to be, I mean, we're talking about quantum and like, you know, two possibilities existing at the same time. It's very abstract, right? But if we're actually boiling it down to like when we're going to look at the cat and it's going to collapse, the factors influencing the weight have to be tangible, natural factors, right?
So at the quantum level, yes, for example.
Okay.
There are a lot of examples we can give in quantum mechanics, which these tangible factors play in.
Okay.
At the macroscopic level, so the cat is a thought experiment, really.
Yeah.
So thinking of it as a quantum system, realistically, doesn't make a lot of sense. But the same analogy you made of, you know, if the cat is eating or sleeping and stuff, you can have the similar tangible factors at the quantum level.
Okay.
With actual parameters, I mean.
Okay, so then just to like wrap it all together, classical physics we consider deterministic because we look at cause and effect and we can predict the effect based on what we know about the causes, essentially. But quantum physics is probabilistic because it's context dependent and it considers like all possibilities at once. Because we don't know. We're uncertain. So then it's only about things that we're uncertain of. But oh man, my brain is going in like so many directions. Like, okay, so then does that have to do with like different people and different perspectives? Because for example, like if you saw the cat, then you would know if it's alive or not in the box, but I still wouldn't know if it's alive or not. So it can exist in one reality as alive or dead, and then exist in another, which is your subjective reality. And then in my subjective reality, it's still both.
So that's a very, again, difficult question.
Okay.
But the short answer is, assuming you don't have knowledge about my observation, the quantum state of the cat in your case is both alive and dead.
Yes.
In my case, I saw it, so I collapsed it.
Yeah.
But again, this goes to the observer-dependent nature of quantum systems.
Yeah.
Which is spooky.
Back. Yeah. So you observing the cat would change the nature of it.
Yes.
Because it's no longer
in a superposition
of both alive and dead.
Exactly.
Whoa, that's so cool.
And then Einstein rejected all of this.
Oh, really?
And he said, God does not play dice.
God. Oh, so Einstein believed in God. He believed in a creator.
I think in a sense he did, in sort of God of order style belief.
Yeah.
But he really was not comfortable with how quantum mechanics worked.
Why?
He very much, I think, was into the idea that physics has to be deterministic.
Okay, so then what does this mean? Because if I think about like the minds, it's not something tangible in the sense that like it's only something that my mind, my thoughts are only something that I can access internally. Each of us has our own subjective reality, right? To me, that's super quantum because it's like you can hold so many different possibilities at once in your mind. And especially in the wellness world, like as we said, people love to almost use quantum as like a buzzword, you know, like it covers their asses when like they don't really want to explain things, or there's no explanation for things. So it's just like, oh yeah, it's the quantum world. But also there's like, you know, Joe Dispenza talks about it a lot, and he's like, his method is hugely successful. Like people really, their lives change because of his meditations and his method. And I've done a lot of his meditations. They're incredible. But he makes a lot of claims about quantum fields and you know, like aligning with certain timelines. And I guess the whole idea, the whole premise behind it is that like when you connect to a feeling in your body, like if you want to, let's say I want to be like a successful doctor, I have to visualize myself as that person and connect to what it feels like to be that person. And through that feeling, you create a frequency that aligns you with that timeline or that possibility. That is like a loose explanation of kind of like what the theory or mentality is. That we can use our bodies and we can use our sense feelings to shift our states and shift realities or timelines. And obviously that's like really bold claims, but practically it works for people. You know, like a lot of people have changed their lives using these meditations. And also like manifestation is all about that, you know, like it really is just about like becoming very clear about what you want and aligning your actions towards it, and not letting your limiting beliefs hold you back, like being entirely like upfront and honest about what you really want, even if you think you can't do it. Also being grateful for what you have now. So essentially letting go of anything like limiting, negative, like comparing yourself to other people's scarcity, letting go of all of these like minimizing factors and opening yourself up like mentally to like total possibility, which kind of sounds similar in a sense to like this idea of like the quantum world is entirely based on possibilities, right?
I think, so this is going back to your first point. People use the word quantum physics very loosely. I think it's useful to draw analogies from some implications of quantum physics. But I also think it's equally slightly misleading if you take the literal outcomes of quantum mechanics, such as timelines, alternative universes, and apply them macroscopically to you.
Right.
This is where I think I draw the line of, or the difference between using analogies like what we tried to do this episode, compared to actually taking the literal outcome and applying it to something macroscopic loosely. So I think you're closer towards the analogy part, which I think is useful.
But if the analogy is that useful, you know, like if you're not taking it literally, you don't have to take it literally, you know, like you can do things with just trust, you know, and especially if it works for you, especially if it gives you like a sense of peace or, you know, a sense of like personal growth, and you're actually moving towards what you want in life. Does it matter if it's literally right or wrong? I don't think so. You know, like, so that's kind of like, again, the distinction. Like there's a difference between like wanting to prove something versus like how are you applying this to your life in a way that's beneficial to your health, to your quality of life, and all of that. So in that sense, we can't like make them like, it's not a one-to-one ratio, right? Like quantum does not mean manifestation. Like we can't make that claim, you know? But at the same time, your mind is really powerful. You know, it's a very, very powerful thing. And I think, we'll get into more about how we can use it. But I feel like there's a lot of parallels we're going to draw here. So yeah, I'm excited about that.
Likewise.